All right, hello everybody. This is Mr. Kyle. Welcome to our geometry lesson for today. We're going to go into chapter 10, talk all about circles and circle properties. We're going to start off real basic in 10.1, talk about some basics of circles and a little bit about circumference. All right, so here we go. Hopefully this works for everybody. I'll perfect it as we go. Well, not perfect it, but maybe get a little bit better as we go. So hopefully everybody has the note sheet or at least can access it via focus. You know what a circle looks like. Here we go. Not perfectly drawn, more like an egg or maybe some type of irregular planet, but it'll do. All right, so circles are named from the center point. So let's say you had a center point and it was P. You could call this circle P. Now, like most things in geometry, there are symbols. So for the symbol for a circle is a little circle with the center point drawn. So you could also name it circle P like such. Sometimes you'll see the little circle symbol drawn with a radius in there. So a couple different names to, couple different ways rather to name a circle. There are a couple different parts of a circle. Most of y'all have heard of the radius and diameter. Radius lowercase r, diameter lowercase d. The plural for a radius is radii. So if you ever see this weird looking word, R-A-D-I-I, that is the plural for radius. You don't say radiuses, you say radii. So over here, a radius is from the center point to a point on the circle. Most of y'all know that it goes halfway across, whereas the diameter goes the entire way across. And most of y'all know that the diameter is twice the radius, or the radius is half the diameter. So the entire diameter D, the radius here R. Now, this is a segment between these 2 points. This is what we call a chord. So a chord is something like this. It's a segment that goes from one point on the circle to another. Now you'll notice the diameter also does that. So the diameter is a type of chord. So a chord is a segment from one point on circle to another. Now, because the chord is a type of segment, you name it or label it just like you would a normal segment. So let's say you had points B and C. Those would be the endpoints of the chord or segment, and the chord would be named like such, just like you're naming a segment. Okay, a couple other properties about circles. If you have circles that are congruent, that means that the radii are also congruent. So congruent circles means that the radius, each radius or the radii are congruent, they're the same length, as well as the diameters. And a little property about similarity in circles, all circles are similar to each other because the only dimension is really the radius or diameter, and you can always make a ratio between those two numbers. So one circle is always similar to another. Moving right along, you might see the term concentric circles. Concentric circles are basically one circle inside of another. Now, it's a little more technical than that. they have to share a center point. So concentric circles, the main thing about them is that they share a center point. Sometimes you'll see each radius drawn in, like the radius of the small circle here and the radius of the big circle there. Now, an example of concentric circles in nature or everyday life are the rings of a tree rings. Environmentalists, botanists, people that work with trees or nature, they can a lot of times estimate the age of a tree by cutting the trunk open and looking at the tree rings. All right, we'll deal with circumference a little bit in this section as well. Most of y'all remember the circumference formula. Capital C is circumference, and that is equal to pi times the diameter. A second circumference formula involving the radius is C equals 2 pi r. So you can use either one of these when you're dealing with the circumference of a circle and problems involving circumference. Make sure that you read the directions in the problem that you're doing. Sometimes they want an approximation for the circumference. Sometimes they want an exact circumference. So remember, since it involves pi, use the 3.14 approximation for pi. Now, some of y'all might have seen the fractional approximation for pi. 22 over 7 also works as a fraction approximation for pi. Exact, do not change pi to a decimal because this is rounded, remember. Exact, use and keep the pi symbol throughout the problem and in the answer. Also, don't take a square root if they want exact. Keep your radical symbol. Keep the square root or radical symbol. All right, that's the first side. Let's hop to the second side. A couple more terms, and then we'll finish with some examples. All right, this figure right here, let's look at this. We have a quadrilateral drawn inside of a circle. So this is center point R, circle R, and this we'll just call polygon ABCD. You might see the terms inscribed and circumscribed. We've gone over those terms before. So you could describe polygon ABCD as being inscribed in circle R. So that just basically means inscribed. It means drawn on the inside of, pretty much. And you could also describe circle R as being drawn around or circumscribed. Around polygon ABCD. Now, a lot of times they don't say around, but they say about. So they might say circle R is circumscribed about polygon ABCD. Now, also a little more technical as far as inscribed and circumscribed shapes and circles is it can't just be any shape that's drawn inside or around another one. The vertices have to be on the circle. So make a note right here. Vertices must be on the circle. All right, we're going to do some examples, 1 through 3 below. Let's look at number 1. These will be similar to some problems that you get in your homework set for 10.1. All right, number one, we're going to find the diameter if the circumference is 63 inches. All right, so since we're dealing with circumference, let's pull up the formula. And let's go ahead and substitute what we know. Well, we know the circumference is 63 inches, so let's replace C with 63. Now, it doesn't specify approximate or exact, so we'll just go ahead and do both. All right, well, we want to find the diameter, which is D. So to isolate D, just divide both sides by pi. It'll cancel on the right. And you'll see that the diameter is equal to 63 over pi. And it looks a little awkward, but that's the way you have to leave your answer if they want exact. And since our unit is inches, if you want to put inches as your unit, you can. Now, if you want an approximation, just do 63 divided by 3.14, and that will give you an approximation for pi, for the diameter. And if you divide that out, you'll get right at about 20 or 20.1. All right, let's move on to number two. I almost said any questions. All right, number two. Now, we want to find the exact circumference. So exact meaning that we want pi throughout the problem and or in our final answer. All right, so you'll notice we have a triangle inscribed inside of the circle. We know two of the sides of the triangle. Now you'll notice this chord is actually the diameter. And remember, not always, but most things in geometry are how they look. And this does look like a right triangle. And in fact, it is. We're going to go ahead and go over a property later in the chapter that says if you have a triangle inside a circle and one of the sides is the diameter, it has to be a right triangle. So here's your right angle. Okay, this means we can easily solve for the diameter by using the ever versatile Pythagorean theorem. Our legs are 10 and 4. Our hypotenuse is D. So if we do a little algebra work here with the Pythagorean formula, now, do we want to punch a square root out here? Good, I hope you said no because we want exact. So our diameter is going to be the square root of 116. Now, we can simplify that a little bit. We can simplify that radical, find perfect squares to break it down, but we'll just leave it like that for the time being. Okay, so we have the length of the diameter. We're keeping it like this because we do want exact. Okay, so since we have the diameter, we can pull up the circumference formula. And we plug square root of 116 in for D. And that is our circumference. Looks a little unorthodox with our pi symbol and our radical, but we want exact, so we're going to leave it like this. And you can tack on your unit, which looks like it's meters. And we have our circumference. Okay, so that is a right triangle, so long as you have a diameter from one of the sides. All right, let's go to number 3, our last problem. We're going to find again the exact circumference. All right, so Let's see what we got here. We have a circle inscribed inside of a quadrilateral. Now it tells us that it is a square. So we know all four of these sides are congruent. Let's go ahead and put a center point in, just because we'll probably need a reference point there for a center point. Now, we want the circumference. So we're going to want to use C equals pi d. The only problem is we don't have the diameter. But hopefully you notice that the side of the square here is the same as the diameter of the circle. And since we're given the perimeter of the square, all four sides being congruent, we can easily find what one of these sides is. So divide by 4. And we come out with 12 for each side. Now we can go ahead, knowing that each side is 12, that is also the diameter of the circle. And now we can plug 12 in for D. And we want to keep pi as pi because we want exact. Now, normally they write the number as the coefficient in front of the pi symbol. So go ahead and just start getting used to doing that. 12 pi is our circumference. And we can tack on a unit if you want, centimeters it looks like. And there we go. All right, guys, notice below I've given you a hint on number 44 in your homework, as well as a hint and some steps on how to tackle 34 if you get confused. And the 3 examples we did should be similar to many of your homework problems. And like always, there's probably a few where you're going to have to think a little bit. Try your best. Maybe we didn't go over it specifically in the notes. All right, guys, check focus for your homework assignment for 10.1, you geometry students. And thanks for listening to me and being patient with these notes. Go ahead and tackle that homework, and probably on Wednesday or Thursday, check focus, and I should be having your second assignment for the week up on focus. So again, Wednesday or Thursday, I'll have your focus assignment and lesson video up. And thanks for watching and listening, guys. Stay healthy. Bye-bye.